For all the elements in the domain, it should have different elements or different images in the codomain. Real numbers is always written in the form of minus infinity, comma infinity. This is how we write the interval form of real numbers. And secant inverse, cosecant inverse have the same domain, that is r minus minus 1, comma 1. So that is x can take the values less than minus 1 or x can take the values greater than 1. Hello everyone, a warm welcome to one and all. This is Yashruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In this session, we are starting up with the new chapter, Inverse Trigonometric Functions. In the chapter Relations and Functions, we have learned what are invertible functions or inverse function. So, whenever a function is bijective, inverse exists. That is, the inverse of a function also exists. Now, we already familiar with the trigonometric function. Does trigonometric functions have inverses? So, let us study the inverse of those trigonometric functions. Now, before that, let us recall what is inverse of a function. Suppose f is a function from a to b is a bijective function. Then the function f inverse from b to a is called the inverse of a function, and it is, suppose if y is equal to f of x, then we write f inverse of y is equal to x. Also note that for inverse to exist, a function must be bijective, that is 1, 1 and onto. So we already know that for an inverse function, if it satisfies both 1, 1 and onto condition, then we call it as a bijective function. All bijective functions have inverses. But what about trigonometric functions here? So, trigonometric functions are neither 1, 1 nor onto over their natural domains. For example, I'll take y is equal to sine x. This is not 1, 1 nor onto. Why? Let us look at the graph of sine x. So, for a function to be 1, 1, for every element, there should be different unique image for the set of all elements in the domain. Then only we say that it is 1, 1 function. So, for all the elements in the domain, it should have different elements or different images in the codomain. But for a sine function, see here, you have a graph here. See here, you have sine minus 2 pi is 0, sine minus pi is 0, sine 0 is 0. Similarly, it goes on, and you can see here sine pi by 2 is 1, sine minus 3 pi by 2 is 1. Similarly, you can also see that here it goes on, and one more we can say here sine minus pi by 2 as well as sine 3 by pi 2 contains the value minus 1. Even though the domain elements are different here, their images are same. Hence, it cannot be 1, 1 function. Now, whenever I take, sine is a function from the set of all real numbers to minus 1, comma 1. So, whenever I take the domain as the set of real numbers and the range of the sine function is minus 1, comma 1. So, this is the actual domain and range of the sine function. But in this domain and range, it is neither 1, 1 nor onto. So, therefore, we can clearly say the trigonometric function cannot have inverse function. But however, the domain of the function is restricted, then trigonometric functions can have inverses. Now, how to restrict the domain of a sine function? See here, you can observe the curve from here to here. So, when I restrict the domain from minus pi by 2 to pi by 2. So, you can take this minus pi by 2 to pi by 2. And similarly, you can clearly say, see the curve here, the value does not repeats here. Similarly, you can restrict the domain from minus 3 pi by 2 minus pi by 2. So, minus 3 pi by 2 minus pi by 2. So, like this, when you restrict the domain separately, the sine function can be invertible, because you can clearly say here, for each values of x, you have only different values of y here. Similarly, here also for each values of x, you have different values of y, and for all the codomain elements you have one pre-image in the domain set. So therefore we restrict the domain of a trigonometric function to make it an inversible function. Now let's study all 6 trigonometric function as its inverses now. Now inverse of a sine function. Inverse of a sine function is a function, we denote it as sine inverse, and it is a function from minus 1, 1 to minus pi by 2, pi by 2. So whenever the sine function has the domain from set of minus pi by 2 to pi by 2 to minus 1, 1. So for all the sine values from minus pi by 2 to pi by 2, you will have the values from minus 1, 1. So the inverse of a function is vice versa. It is from minus 1, 1 to minus pi by, pi by 2. That means the inverse of all trigonometric function gives only the values of angles. So therefore, we have sine inverse function from minus 1, 1 to minus pi by 2, pi by 2. We also call this minus pi by 2, pi by 2 as a principal value branch. That is also nothing but the range. So the domain of the sine function can be restricted to any sort of intervals, but the interval from minus pi by 2 to pi by 2 is called as the principal value branch, or we can say the range of the sine inverse function or inverse of sine function. Now, how we define the inverse of a function? Suppose we take y is equal to sine inverse x, then we can write sine y is equal to x, where x take the values from minus 1 to 1, because this is the domain, that is x can take only the values from minus 1 to 1 and y can take values from minus pi by 2 to plus pi by 2. This is how the inverse of a function is defined. Let's see the graph of the sine function. Clearly you can see this is what the interval I have taken from minus pi by 2 to plus pi by 2. Sine 0 is 0, sine pi by 2 is 1, sine minus pi by 2 is minus 1. So these are the points with respect to pi by 2, 0 and minus pi by 2, and this is the graph of sine inverse function. Hence we can say the domain and range. So thus we can write the domain of the function is from minus 1, to minus 1, and the range is from minus pi by 2 plus pi by 2. So this is the domain and range of the sine inverse function, and this is the graph of the sine inverse function over the interval minus pi by 2 to plus pi by 2. Now let's see inverse of cosine function. So inverse of cosine function, it is similar as we defined in the case of sine inverse. So cos inverse is a function from minus 1, 1 to 0 to pi. We know the graph of cos, it is also continuous like this. That means for many of the values, cosine function is neither 1, 1 nor on 2, because we have a repeated interval of values for cos function also. Hence, we restrict the domain of cos function also so that it will become an invertible function. Thus, we define the inverse of cosine function from the interval minus 1, to 0, 5. Here, in the inverse function, the domain of the trigonometric function is always a real number and the range is always the angles. Now, how we define cos inverse function? We take y is equal to cos inverse x such that we can write the inverse in the form of cos y is equal to x, where x is a domain value which lies from minus 1 to 1 and y lies from 0 to pi. So this is the domain and range of the cosine function. As in the case of sine inverse function, we have a principal value branch for cosine also. So we take 0, pi as the principal value branch of cosine function. Let's see the graph of cosine function. So this is the graph of cosine function from the interval 0 to pi here. So you can see here for cos 0, the value is pi by 2. For cos 1, the value is 0. And for cos of minus 1, the value is 5. So this is the pi and this is the value pi by 2 and 0. So this is how the graph of the cosine function exists, and thus the domain is same, that is the domain of cos inverse function is again from minus 1 comma 1 and range is 0 comma pi. So this is the domain, range and graph of cosine function. Next one, inverse of tangent function. Thus, inverse of a tangent function is defined from the set of all real number to minus pi by 2 comma pi by 2. So because we know that for pi by 2, the value of tan is infinite. So therefore, we have taken here an open interval. So we cannot include minus pi by 2 to plus pi by 2 because the value of tan function in pi by 2 and minus pi by 2 is infinite values. So therefore, we will write this interval in the form of open intervals. Now, how we define the tan function here? So we take y is equal to tan inverse x such that x can be written as tan y, where x take the values from minus infinity to pi plus infinity. Why? Because the range is from minus pi by 2 to plus pi by 2. Also remember, here we will not write in the form of less than or equal to, because we have taken an interval and real numbers is always written in the form of minus infinity comma infinity. This is how we write the interval form of real numbers. So therefore, x take the values from minus infinity to plus infinity, thus y take the values from minus pi by 2 to plus pi by 2. And this one is again called as the principal value branch of the tan function here. This is how we define the inverse of a tan function. Let us see the graph of tan function. Since the domain is range is restricted, so here we have taken minus pi by 2, 0, and this is a straight line, y is equal to pi by 2. So this is how the curve goes. We know tan 0. So here for 0 it is 0. So tan 1 means pi by 4, tan minus 1 means minus pi by 4, and thus it goes on. Tan minus pi by 2 means it should reach until minus infinity. Tan plus pi by 2 means it should reach until pi by 2. So this is how the graph of tan inverse function or inverse of tan function defined. Now again, the domain is the set of real numbers and the range is from minus pi by 2 to plus pi by 2. Next one, inverse of cotangent function. Again, the inverse of cotangent function is a function written in the form of cot inverse from r to 0 comma 5. Again, r is nothing but minus infinity comma infinity. Thus, the domain value, that is x, lies from minus infinity to plus infinity and y lies from 0 comma 5. So here also 0 comma pi is written in the form of open interval. And we define cot inverse in the form of y is equal to cot inverse s such that we can write it in the form of cot y is equal to x. And the interval 0 comma pi is called the principal value branch of inverse cot function. Let's see the graph. So this is the line y is equal to 0 and this is the line y is equal to pi here. So a function is cos inverse x. So we can clearly say, so here for 0 it is pi by 2, for 1 it is pi by 4, for minus 1 it is 3 pi by 4. So clearly the values include here. So this is minus 1 and the point is 3 pi by 4, and this is for 1 it is 1 comma 5 by 4. And again for 0 it should take the plus infinite values, and for pi it should take minus infinity value, because cot pi is infinity and cot 0 is also infinity. Hence, the curve goes like this towards infinity. So this is the graph of cot inverse function. Next one, inverse of a secant function. So inverse of a secant function is thus defined in the form of secant inverse is equal to r minus 1 comma 1, 0 comma pi minus pi by 2. That means the domain should not take the values from minus 1 comma 1 and range does not contains any pi by 2. So therefore, how we define this function? We define y is equal to secant inverse x such that secant y is equal to x. Now, what does this means? R cannot take the values between -1 to 1. So if this is the real number line, so we have -1, 0, +1. So you cannot take the values between this. So therefore you can take less than -1 and greater than 1. That is why the domain element have a condition. It can have the values x less than or equal to -1 or x greater than or equal to 1. And similarly here y can have all the values from 0 to pi by 2 except pi by 2. Y cannot take the values of pi by 2. Now what is the principal value branch of secant inverse function? Obviously the range is given by 0, pi minus pi by 2. So this is the principal value branch of secant inverse function. Next one, this is the graph of secant inverse function. So I already said it cannot take the value of y is equal to pi by 2 since it can take a values less than or equal to 1 and greater than or equal to 1. So for if this is -1 here and if this is +1 here, so this is how the graph of the chord functions goes here. So it can take the values less than -1 towards infinity because secant pi by 2 is infinity. So therefore the graph lies down here and it moves towards infinity and to the point 1. So after point 1 the graph moves towards a plus infinity. So this is how the inverse secant function have here. Next one, inverse of cosecant function. So the inverse of a cosecant function is a function defined as cosecant inverse is equal to r minus -1, 1 and the range is from -pi by 2 to pi by 2 except 0. So the condition here, the domain elements can take all the elements of real number except from the interval -1 to 1. As I defined in the case of secant, here also x can have the values less than 1 and greater than 1. And similarly, the range lies between -pi by 2 to +pi by 2 except y is equal to 0. And the principal value branch for cosecant inverse is -pi by 2, pi by 2 minus 0. Let's look at the graph of cosecant inverse function. So I already said, so if this is a +1 and -1, so cosecant value can take the values after 1. So for after 1, 1, 2, 3, the graph of the function goes like this because for cosecant 0, the value is infinite. Hence it moves towards infinity. And similarly, it can take the values less than 1. So therefore, less than 1 means, so the graph starts from here. So for -1, it is -pi by 2 and for +1, it is pi by 2. So the graph goes like this and this is the point -1, -pi by 2. From here, for all the values less than 1, the graph of the cosecant function move towards -infinity. Thus, the domain we say it as r minus of -1, 1 and this is the range of the cosecant function. So now let's study the function, domain and principal value branch, that is the range of the inverse function. Now for sine inverse, the domain is -1, 1 and the range or the principal value branch is -pi by 2 to pi by 2. For cos inverse, the domain is -1, 1 and the principal value branch or range is 0, pi. Remember to write the square brackets for sine and cos. Next we have tan inverse. So for tan inverse, the domain is set of real numbers and principal value branches -pi by 2 to +pi by 2. Here you should take an open interval because it is -infinity to +infinity. Next we have for cot inverse, it is same. Domain of a function is r and range is 0, pi within the open intervals. And secant inverse, cosecant inverse have the same domain, that is r minus -1, 1. So that is x can take the values less than -1 or x can take the values greater than 1. So the domain of secant and cosecant is same, but the principal value branch for secant function is it can take all the values from 0, pi except to pi by 2. That is why we have taken 0, pi minus pi by 2. Similarly, for cosecant function, it is minus pi by 2 to pi by 2 except 0. That is why we have taken a square brackets minus pi by 2, pi by 2 minus 0. So the principal value branch, they may ask you for 1 mark question. That is, write the principal value branch of cos inverse function, write the principal value or write the range of sine inverse function, or write the domain of tan inverse function. So this is how you should learn the domain as well as the principal value branch of the all 6 trigonometric functions. So this is how we define the inverse of a trigonometric function. We'll take the properties and the problems related to inverse trigonometric function in our next section. Until then, keep watching, keep learning, keep exploring. Thank you.